Hello everyone and welcome to yet another recreational programming session with Mr. Zozin. So here we have a very simple demo for a very interesting library which is called Olivec or Olivets, depending on how you want to pronounce it. And this library is rather cool in a sense that it doesn't use any sort of like graphical APIs by itself. All it does, it renders everything into the array of pixels, into the buffer of pixels that you're supposed to allocate yourself. And then you can do whatever the hell you want with that array of pixels. For example, put them into HTML5 canvas. This is a C library. This is generated by C library, compiled to WebAssembly, and then this library generated an array of pixels, and we just put it into the HTML5 canvas. It doesn't use WebGL. It doesn't even use WebGL2. And it doesn't use a web GPU. It literally just uses HTML5 canvas. Because it grabs the array of pixels, just grabs them, puts them in the image data, and just slaps the image data onto the HTML5 canvas. That's how it works. That's how cool it is. So, right. So on the previous stream, we were working on actually converting the OBJ file of this penguin called Panger. His name is Panger, right, to a format where we can actually display it through this library. But this particular OBJ file contains way more than just vertices and faces. It contains also textures, and we do not really display them because we don't really know how to do that yet. So today's stream is going to be dedicated to, making the textures appear on this OBJ file, right? So I think I tried to open that OBJ file through Blender and I couldn't see the actual materials and stuff like that. So OBJ file itself, right? And OBJ is a format for like a 3D models and stuff like that. So it has vertices, as you can see. It has additional things for normals, right? So here are the normals. Then there is a textures, right? Texture coordinates and stuff like that. And after that come the faces, which are the triangles essentially, right? And here is just like indices that corresponds to vertices, texture coordinates, and the normals and stuff like that. And also this particular OBJ file refers to a material file, MTL, right? So which describes the material of the Panger itself, right? And it refers to a texture, right? So which is basically put on top of the Panger. So this is the texture, but I mean, it looks like a nonsense, right? But essentially it's up to the, the texture coordinates to actually put everything in place so it looks good. Right, that's kind of the point, if I understand correctly. Right, so it's going to be rather interesting. So our goal for today is going to be to understand the vertex coordinates and map them correspondingly to the PNG file and just display it as a texture. Luckily, we already know how to display textures on 3D faces, right? So in these demos, which you can find in the description, I'm going to put the link to these demos in the description. We have this demo that demonstrates how you can do that, right? So essentially we have two triangles and we just put some textures on these two triangles. So since we know how to do that, we can port that to that demo, right? So we have a couple of 3D things in here. Right, and we'll be able to have like a textures on this penguin. So somebody on Discord warned me that the OBJ model is rather peculiar in the sense that it has a transparent shell around it. So we have to be careful with this kind of stuff, right? So that means even if we start handling the textures and texture coordinates, we won't be able to see the actual texture of the penguin because of the outer shell. And outer shell serves as sort of like a hack to make the penguin look cartoonish. Right, so it kind of makes sense when you look at it through the Blender, but we couldn't look through the Blender because I couldn't know how to properly export it. So somebody told me, I think on YouTube, that you have to enable like a material mode or something like that. So it recognized my material file, but it just, we were not in the right sort of like mode or something. So let's actually see. So let me maybe go ahead and delete this cube, and I'm going to try to export, actually import the waveform. So I don't know if I have to be legacy or not legacy. It doesn't really tell me like what exactly it has to be. So I'm gonna copy paste this entire path in here. So then I can just grab the OBJ file. Right, so here it is. And I don't really remember how you enable the, okay, material preview. Okay. Oh, shit. It actually became very slow. I hope it's not gonna kill my entire stream because, oof. So, wireframe, rendered. We can try to see maybe rendered. Yeah, it doesn't look like anything, honestly. So I didn't see any material in here. Oh, here's the material though. Top right corner, button for showing the material. I didn't see it. Antimatter penguin. The orbs. Dude, there's so many fucking things in here. These ones, okay. Viewport shading. Like, dude, somewhere in the right top corner there is a button. Dude, like somewhere in the right top corner there is a button to do this thing. I swear to God, Blender people. Oh my God. So fucking funny. Okay, so there's this thing. It doesn't do anything, right? So it's useless. I see. Okay, so it's a waste of time. I see. It's a waste of time. Don't save. All right. So fuck all of that. Let's actually just jump into all of this entire thing and start maybe parsing all of the necessary information that we will need to make the textures appear. Right. So let me actually see tools, OBJ2C. So the thing is, if we take a look at the at the faces specifically, let's actually find the face. There are 3 triples, right? So basically there's 9 numbers in here. It's 3 triples. So, and the first value in the triple is the index of the vertex, right? So because face is a triangle, and each vertex of the triangle is actually indexed in a global array of vertices, right? So, and the other thing here is for each vertex, I think it's the coordinates, right? So maybe coordinates or maybe normals and stuff like that. So what I'm saying is that as of right now, we only parse the first index in the triple, right? It's only the first index in the triple, and the other 2 are simply ignored. So the first thing in actually making it work probably would be to parse all of the indices in here. Right, so the code that is responsible for parsing all of that is located in OBJ2C. Right, and when we encounter a face, I think it's just F, yeah, there we go. So when we encounter a face, we just do the textual parsing and stuff like that, nothing particularly special, and then we make a face. Right, so there is a function that makes a face. So what's interesting is that it's just a structure of vertex indices. It's a vertex indices. So we'll need to introduce the indices for the vertex textures and the indices for the vertex, what is that, normals, right? So I'm thinking how we're going to be going about that. So these names are very obscure, right? So I would like to maybe rename them to something like VA, VB, VC to indicate that they are essentially the vertices, right? So or maybe it would be better to even call them V1, Zulu, V2, and V3, right? So then later I could introduce things like VT1, VT2, and VT3, right? So VT, and then also VN. Right, so and here we're gonna have like 9 numbers in here, right? So we're gonna have 9 numbers. So it's gonna be V1, Zulu, V2, and V3. And in here, let's just go ahead and do V1 for now, and this one is gonna be V1. So V2, V3, and we just simply return the entire thing. So we use this function only in a single place. And I feel like I need to do the renaming in here as well. So I'm going to just rename V1, V2, and V3. So that will break in all of the places. And we're going to just go through the compilation errors and fix them. So I'm going to do tools. Please break in all of the necessary places. Okay, so here is the V1, V2, V3. So what's the next place? Okay, so these are all of the 3 places. So A is a V1. Right, so this is a V1. And this one is V2. Maybe I could have just used replacing of this entire thing. And this is V3. Let's go V3. Okay, so that's V1, V2, V3. Cool. Anything else? I think that is almost it. Aha, so we also need to do -1 because in OBJ files, the indices are 1 based. So just like, don't look at me like that, okay? So I didn't invent that format, right? So stop looking at me like that. We just have to deal with this kind of shit. Based. I swear to God, people. Didn't you hear Dijkstra? Dijkstra said 1 based indexing bad. Listen to Dijkstra. Dijkstra also said that Go2 is bad. Dijkstra have said a lot of things angrily. It would be kind of funny to see Dijkstra living in the age of Twitter, honestly. I think he would have had the most epic rants on Twitter. Too bad and he even had to invent his own Twitter to rant on. Right, because he wrote like these EWDs, basically. So he would write some rants, and he would just mass print them on a printer or something like that, on a photocopy, and just mass produce them in his university. That's how badly he needed Twitter to rant on. He was just born in a wrong age. He literally was born in a wrong age. He literally had to print down his tweets and just distribute them physically, right? He was suffering like that. If only he actually was born a little bit later, so he could put all of that on Twitter. Mega based, yeah. It was actually kind of funny. So it was before the internet was like a very available thing. So it basically was his physical blog, essentially. Yeah, he was ahead of his time, honestly. He was ahead of his time. Born too soon to be shouted at by morons, yeah. I suppose. Okay, good. I guess we didn't break anything. Everything seems to be working. So we need to start parsing the rest of the things. So I think there was a to-do. Oh yeah, I even put myself a note. Look at that. So I know now that the second thing in here is VT. Right, so I freaking know that, brother. So essentially, what did we do in here? We parsed... So we have this thing, right? So we essentially have this thing, and we parsed the stuff successfully. So that means after doing a switch chop left, we chopped off this thing, and then with this thing, we basically chopping everything off until we encounter like a space or whatever. So what I'm thinking is that we have to do, right, so I'm going to put a comment in here, is that after we chopped the number, the first number that we parsed, we need to take a look at whether the line starts with slash, right, because that's an invitation to parse VT1. That's what it is. It's an invitation to parse VT1. So how we can do that? If data 0 is equal to slash, we have to chop that slash off, right? So chopping that slash off, but we have to be a little bit careful that we're looking at the first character, but the line may not have a first character. So we need to first check that the line count is greater than 0, right? So that's what we need to check. right, is greater than 0. Then we do that, blah, blah, blah. Everything's good, everything's Tamaguchi. So, and after that, we should try to parse VT1, right? So VT1. But I think it should be available outside of the scope of these conditions. So I think we need to put VT1, we have to declare it in here. So let's put 0 in here, indicating that it doesn't exist. Then we parse it like that. Right, so then we parse it like that, and then we chop it off like this. So we also do a little bit of a checking of the ranges. So we compute in the low index of the face and high index of the face. This is needed for the statistics. We could do that for the textures as well, but I don't think I really want to do it right now, right? So I'm not sure if I care about it that much. But anyway, so afterwards, after doing all of that, right, so we essentially chopped off that slash in this line, right? Then we chopped off this number with these two lines, and effectively we parsed the VT1. Cool. So after that, we probably want to repeat the whole thing, but for Vn, right? So we can even like literally copy paste this entire thing and just like query replace VT with Vn, right? So VT with Vn, and it's going to be basically that, right? So, and after that, if there's some additional stuff in here, we just like don't really care about it. We're just like, you know, chopping it off. That's about it. I think we can even copy paste now this entire thing twice for the second thing, right, in front of this while. But the thing we have to do in here is that we have to replace 1 with 2. So we replace 1 with 2, but we have to be careful, right? So because we don't want to affect this one, for instance, right? So let's ignore these things. Like so. And now we can copy paste this thing for the third one as well. So I'm going to just put it in here, select this entire thing, and replacing 2 with 3 is a little bit easier because we don't have any extra 2's in here. And effectively, we parsed everything, right? So there is a little bit of duplication, but I'm not sure if I want to fix that duplication. We could actually fix it. We could maybe factor out this entire thing into a separate function which accepts v1, like v, vt, and vn as pointers to the integers and just like puts them there. And that maybe could compress this code just a bit. Right, but the thing here is that now we have to pass all of these things into makeface, I suppose, right? So let's actually pass them into makeface. The way we can do that, this one is going to be VT, so this is VT, and then I'm going to copy paste this one more time and replace with VT with VN, VT, VN, boom. Right, so this one is could replace V with VT, boom, and this one with T and boom. Look at that. Can your Vim do that? Can your Vim do that? I don't. So yeah, your Vim can't do shit. So now we have to pass all of this information somewhere there, right? So let's do it like that. So this is could replace V. I forgot to put V. Could replace V, VT, boom. And now boom. VN could replace VT, VN, boom. Look at that. Look at that. So we can try to now build the tools and see where it fails. Oh, I'm in the wrong place. So building that tools. What's Vim? That's a good question actually. So got some beats from Enumerate. Thank you so much for 100 bits with the message. Hello, Mr. Zodin. Good luck with the graphics. Thank you so much. MTSF777. Thank you so much for tier 1 with the message. 69 with Zozin. Oh, you mean 16? Yo, it's a funny number. It's a funny sex number. Thank you so much. Thank you so much for supporting me for so long. Thank you, thank you, thank you. Cheers, by the way. Funny number. funny number 69. So yes, we don't really do anything with these additional numbers, right? So we don't really do anything with them except storing them in memory. So I don't really know how we want to, approach all of that stuff. So it would be interesting to maybe go through this process of parsing things in a debugger, right? So first of all, let me just build all of this thing. And on top of that, I would like to maybe rebuild the assets, right? So everything seems to be fine in here, right? So everything seems to be fine. And we probably want to rebuild the demos, right? So can I do demos and then WASM, rebuild only the WASM demos? No, this is not how I do that. Oh, it rebuilds just everything. I forgot how to... I remember there was a way to just say, okay, rebuild only WASM demos. Now it rebuilds everything. Okay, let's rebuild everything, whatever. So at Ski, thank you so much for Twitch Prime for 12 months. Thank you, thank you, thank you. Thank you, thank you, thank you. So it's SDL and terminal and stuff like that. We need to check that we didn't break anything. So because some of the OBGs don't have that slash thingy. That's a very important thing. So we need to actually parse it in a way that ignores, that doesn't break the OBGs without the slash things. So if I take a look at the Utah teapot and find the thing that starts with F, there we go. So as you can see here, you have only the vertices, right? So some of those things are kind of optional, right? So, and we need to have a code that supports all of that and doesn't break, right, at all. So do we have the Python? Okay, so I'm gonna just restart this entire thing and let's take a look at the demos in here. Okay, so the demos are not broken. Everything is working, everything is working. One of the things I would like to do actually is to maybe, when I do tools, right, so I'm running, maybe assets actually, right, so that's what I'm doing. So I'm running obj2c. Right, so that's what I'm running, like this. Cool. And now, what I want to do, I want to actually do gf2. Right, and I want to just open this entire thing in the debugger. So where I'm going to be debugging, in which place we're going to be debugging all of this entire stuff. We're probably going to be debugging somewhere here. It's a line 289. So break obj2c. 289. All right, so if you take a look at the breakpoints, so here is the place, and let's actually run this entire thing with these parameters, basically converting the panger. All right, so this is what we have in here. We're looking at the line. So let me bring all of that stuff a little bit closer to here. So here is the line, and as you can see, we're looking at 23.123, which corresponds to the line somewhere in the assets obj file. So it's a 21/23, right? So 23/1. So here it is. So we're parsing the first phase. So let's see how it will perform that. Let's see how it will perform. So we might as well even take a look at things like v1, v2, v3, right? So, and maybe vt1, vt2, vt3, and vn1, vn2, vn3. That's a lot of things in here, but I think it's fine. All right, so we parse in v1. v1 is 23, so we're just updating this kind of thing. Then we are chopping the number that we just parsed. Right, so we initialize vt1 with 0, that's fine. So we see that this entire thing starts with the slash. We're chopping off the slash has been chopped off. Then we assigning 1 to vt1, and then we chopping this thing off. All right, so then we have slash. We see that slash is there. We removing it. Then we parse the next number. And there we go. So 23, 1, 23, v1, vt1, vn1, 23, 1, 23, 23, 1, 23. We parse this entire thing successfully. We can clearly see this entire thing. So after that, we just continue parsing the rest of the things, right? So we parse v1 to in here, and I think we can already safely say that this thing is working, right? So it's working as expected, and we just like parsed all of the indices in here pretty successfully, I gotta say, right? So we have all of that necessary information that we didn't have before, right? So now we know the indices of, you know, texture coordinates and the normals and stuff like that. So that's pretty cool. Okay. So Derek Cry, thank you so much for gifting this sub. Bones Boz, thank you so much for Twitch Prime with the message. It's Panger time! There is a new hidden secret page at Panger City. I think I know which one you're talking about. Alright, so let me take a look at this thing. So it's Jedgar. So, and you can access, so there is a Jedgar in here, and you can access it by actually clicking at him. And so there is a Jedgar page. Right, so which plays a very cool tune. So actually kind of cool. I can't really hear it, but yeah, it is playing. So maybe this is what we're going to be listening in the break. We'll see. Okay. So what we can do now, I feel like I want to actually factor it out. All right, so I feel like I want to factor it out. I think it's going to be very, very beneficial for us. So let me see how we can do that. So we need to come up with a name for the function that is going to be parsing the triple. Right. So we can call it parse face triple. Is that a good name for this thing? Parse face triple. Right, and we probably want to start with passing this thing. What's funny is that it's modifying the line, so that means the line has to be passed by a pointer, right? So that's the first thing we're doing here. And also it is updating LFHF, and LFHF, are they global? I don't think they're global actually. Yeah, so they're not global, so that means they also have to be passed by a reference. All right, so int LF, int HF. And most importantly, we have to pass the V, like everything, like all of these things in here. Not really everything, but we need to pass V, which is a pointer, then V T and Vn, right? So all of these things will be passed by a pointer. So what I'm thinking, I need to go to the compilation errors in here, so it's going to be that. Right, so it's going to be nobuild, not really nob, right? It's nobuild. So this is the tools, and let's go to the compilation errors. Okay, so this is the line. We have to dereference it. No auto dereferencing in C, unfortunately. This is not C3, but even in C3, our auto dereferencing is kind of limited, right? So I think auto dereferencing works a little bit better in Jai, but I don't remember the rules of auto dereferencing in Jai, honestly. I don't remember them, right? But I can remember that they were rather convenient, right? So yeah, you didn't have to even think about it too much, right? So it was pretty straightforward to just change from passing by value to passing by reference, right? And this is something that I really like. But in C, not only I have to like now put all of these stars in here and shit like that, I also have to replace the dots with arrows. Freaking classic problem. Right, so there's also end ptr, which probably gonna be a local variable here somewhere. So how do I declare it? So it's basically just a pointer to the character, so I'm gonna put this stuff in here. Right, so yes, and let's actually maybe do something like v1 v. Does it look even good? I'm not sure if it even looks good, but one upside is that here I don't have to take a reference because line is already a reference, right? I don't have to take a reference in here. So in here we have VT, and I might as well just quickly replace VT1 with just VT, boom, boom, there you go. So in all of the places where we take the pointer, I don't have to do that, but here I have to do this kind of thing. C. Am I right? Extremely ergonomic language. Extremely ergonomic language. Still somehow more ergonomic than Rust, but that's that's a story for another time. So let's replace vn1 with vn, boom, boom. Maybe I'm gonna query replace ampersand line with just line. Can I do that? I apparently can do that. So, and in here, yeah, so that seems to be fine. And also query replace line dot with line arrow. Boom, 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 boom. I want you in my room. Okay. Spend the night together in my room. So a bunch of useless changes. Right, so I probably have to do this kind of thing. So a bunch of useless changes, and I think we are ready to try to compile this entire thing, and I do not guarantee that it's going to work after that. Right, is it going to work after that? No, it doesn't work after that, because fuck you. Because yeah, I have to dereference this, and oh my god, this is so this is so anal. Like, yeah, I have to look at this piece of code. Look at this shit. Look, it's like, oh my god. All of them has to be dereferenced. Like, honestly, this thing would have been much better as a macro. That's for sure. Because it just like wants to have this thing in the local scope. Right, so, and that's basically what we end up with. So this is a job for a macro, but multi-line macros in C are an absolute ass. So it is what it is, and it isn't what it is. And so we're basically passing an entire freaking scope by a reference just to, you know, collapse a little bit of a code. And I'm not sure if it's even worth it after that. So we'll see how it goes. All right, so why data? What the fuck is why data? It's just a data. Why data? Why? All right, so we did it. They're fine. Just scope them. Yeah, I guess. I don't fucking know. Scope them, scoping them. I don't know. Let's go and find a place where we do all of that. So that function will enable us to replace a single code, replace a single chunk of code like this. Hopefully, we don't know yet. So parse face triple, let's go back in here. Right, so, and essentially I can now pass this thing by a pointer and all of these things by a pointer, like so, boom. And this one's going to be V1, T1, and N1. So, and that replaces the whole chunk in here. And in fact, I can now do query replace 1 to 2, boom, and that replaces another chunk, and I can do 2 replace with 3, and that replaces another chunk. Boom, look at that shit. So now when I encounter a face, I parse first face triple, then I parse the second face triple, and a third face triple, and all of the information that I parsed, I just make a face out of that. So I guess it was worth it at the end of the day. You were laughing at me with all of the stars and pointers, but look how much we fucking compressed, mate. Look how much we fucking compressed. Isn't that fucking poggers? Look at that clean code. Look at that clean code. Isn't that clean code? It's fucking epic, mate. So yeah, that's pretty cool. We don't even need to have end pointer in here anymore. Well, we don't know if it compiles or not, so, but yeah, we'll see. I want to kind of go to parse face triple, and I just want to put some information of what goes where, and but I mean it's already there, right? So so first comes V, then VT, and then VN. We don't have to do anything. All right, so let's try to compile this entire thing. So this is the tools, and it doesn't even fucking compile, mate. It doesn't even fucking compile. Why? Oh, because I never allocated on any of these motherfuckers. That's why. That's literally fucking why, because I forgot to allocate all of them. So let's actually put a comma in here, and you know what? This is the first time when this feature of C is kind of convenient. Look at that. This is kind of convenient, isn't it? I just like allocate like all of these variables, then I'm passing the triplets of these variables into this function. There we go. Right. So compiles first fucking try. We showed those doubters their place. Cheers, bye. So many stars, it looks like the American flag. Hell yeah, brother. Okay, cool. Okay. So, the code of freedom. There should be 50 of them actually. It works. It works. So I don't really know if it works actually. So let's rebuild the assets. The assets don't really break that much. There's warnings, but those warnings are kind of key-coded. Key-coded. But those warnings are kind of expected. So let me see how we do. So can you do help? Oh, we have help. Right, so I can do yo, I can do demos, and then I can do platform, I can do wasm. No such directory. So this is a lie. Who wrote this code? No. Who wrote this code? Bruv. The fuck? Anyways, whatever. I don't care what exactly it does, but... Anyways. So maybe I can take a look at the nobuild. Because I only want to rebuild the wasm logos. Demos, not logos. So let me see. So here's the demos. And then we look at some arguments. And then wasm. And then we're looking at the name. It's kind of sus. It's kind of sus. So build SDL demo, but then it expects the name of the demo, I suppose. Right, that's what's going on in here. So no build demos wasm penger. Right, so that's what that still doesn't work. Wasm run. I don't remember how to use my own build system, so whatever. Fuck that. So demo name platform run. Oh, okay, I see. So maybe that's what we have to do. You know better. So penger. Yeah. No file. It's still. But then it says no such file penger C. When obviously this is not true. Here's the. It's a Penger 3D. Oh, I figured it out, guys! I figured out how to use my own build system. Hell yeah, brother. Hell yeah. So, yeah, we should probably rewrite it. And no, by the way, we're still using old no build, actually. We're still using old no builds. I probably need to modernize it and also make the command line arguments more ergonomic. So it's called no build for a reason. No legacy. God fucking damn it. So yeah, we're having the situation of like a legacy mode and non-legacy mode, and it's like, bruv. No build is a philosophy. Somebody asks, what is no build? No build is not really as anything specific, it's a philosophy. Which is very much applicable to C++ code, because C++ code bases are kind of infected with a very dangerous and destructive mind virus of build systems. People in C++ community strongly believe, that they must build more and more build systems that generate building scripts, that generate building scripts, that generate building scripts, that generate building scripts, that generate building script, and all of that is somehow freaking justified. And each chain in building script generation is a completely separate language. And there is this like a tower of building script generators on top of building script generators on top of building script generators, building script generators on top of building script generators, that it's eventually gonna start falling over. Bruh. Like, what's funny is that all of these freaking different languages for different build systems are basically Turing complete languages, essentially. They're basically Turing complete languages. And you as a C++ programmer already have a very powerful Turing complete language, which is called C. yet you feel the need to have another one for the sake of some sort of a perceived convenience because somebody on the Hacker News told you so, or whatever the fuck it is, right? So I think if you have a language, and one language, and you have a project written in that language, the only thing you must have to build that project in that language is only the compiler of that language. Would it be cool if you had a C project and literally the only thing you needed to build that C project is just a C compiler? A C compiler did the entirety of the job. No CMake, no make, no Ninja, no automake, autoconf, auto your mom, or whatever the fuck it is. Like, it's just a C compiler. Just a single fucking C compiler, and like you can build the entirety of the big project in this entire thing. The idea of no build, it's not anything in specific. It's again, it's an idea. Is that you write in your build script in C. You write in your build script in C. And essentially, what you do, you have several stages of building the project. The first stage of building the project is going to be bootstrapping no build program, right? Literally, the only thing you need to do is just say, okay, I have a no build.c in here. If you open it, it has a bunch of things. It has a lot of things in here, right? It does a bunch of things. Okay, but I, as a C programmer, do one single thing in here. I just do cco no build.c. As simple as that, nothing more, nothing less. Anybody who wrote at least Hello World in C can do this kind of shit. Just bootstrap the build system, the build thing. It's written in C. Then you just run it and it builds everything else for you. And it does that by also using C compiler. So essentially you write a build system for your project in C. And it has several phases. You bootstrap the first phase, and that phase builds maybe more additional tools, maybe more additional phases, and just calls them, and this entire thing sort of like just builds itself by only using a single C compiler. No CMake, no automake, no additional languages like Python, no even Bash. You don't need any of that shit. You already have a very powerful language that can build your entire project. Why the fuck do you need to invent more and more and more fucking languages? I'm telling you, this is some sort of a fucking mind virus. It's infecting people's brain. I have no idea why the fuck it does that. You already fucking have everything. People, stop. Get some help. So that's basically an idea. An idea is to have some sort of like a small library that implements basic building blocks for you. Like, for example, run an external shell command. So then you can just like use C as basically as a shell or something. And since C is a proper Turing complete language, you can do very complex logic in this language. Way more complex than in CMake. And it's going to be way more convenient than in CMake. Because CMake is a pretty shitty language, honestly. I wrote complicated stuff in CMake, right? So one of the things I had to do as of recently, right? So in C3, by the way, in C3 there is this feature where you do C3 version, right? And it actually prints you git hash. Bruh, C3 uses CMake. Baking git hash using CMake is a fucking barely solved computer science problem. Like, holy fucking shit. It's fucking insane how unreasonably hard to just bake git hash in a reliable manner so it invalidates and reruns the necessary targets at the right time. And it doesn't rerun it too often so it's too annoying or anything. It's goddamn fucking insane. It could have been just a single condition in C. But we have to deal with this shit. So it's so fucking dumb. It's insane. And we brought all of that shit upon ourselves. So anyway. Yeah. Let's address some subs. So thank you so much, Ledens, Ledinets. Thank you so much for Twitch Prime. Zorkenheimer, holy shit, I haven't seen you in a while. Thank you so much for 70 months of tier 1 subscription with the message. But what if I want to make a new language to compile my program that does work half the time? Well, I mean, your program, like, you can do whatever you want in your program, right? So it's just like, I'm probably not going to be contributing to it. So the thing is, when I talk about certain sort of like ways of developing things, this is the things that I primarily going to be using for myself. When I'm advocating this kind of thing, I do realize that people who already use CMake and all of these build generators, they're probably not gonna like one day switch to this kind of approach. Not only because they are deep down ideologically into this sort of idea of building towers of abstractions, right? But also because it's sometimes technically impossible. Right, because you already have a huge project that is business critical, and touching anything in that project is basically setting yourself up for a failure. Right, so, and this is why, for example, in C3, I didn't push any of my ideas on C3. I just sat down and implemented whatever the fuck I needed in CMake because it's not my project. What I'm saying is that when I'm advocating my ideas, I'm just saying that this is the world I personally would like to live in, right? So, but I do realize that not everybody is going to accept that, right? So this is something that I'm going to use in my projects. And if you want to do something else in your project, fine, right? So that's fine for me, right? I'm just saying, I'm just pointing out the certain inconveniences, right? So I'm just saying that maybe world would have been better if people stopped doing this kind of thing, but I do realize also that we're living in the real world, and like real world is not perfect, and we kind of have to live with all that. Yeah. So again, so people think that I'm very much like ideological person, that like everything is just like has to be like that, like that, like that. But at the same time, I just sat down and spent several hours implementing this thing in CMake, right? So yeah. Even though I'm constantly talking about some ideal world out there, I'm also actually very much like a grounded person, grounded to reality. And if I need to do something in reality, I just sit down and do that. Right, so yeah. But here's my stream, here's my world. So, and I'm just like talking about, like fantasizing about, you know, how world would have been better if it was like that. So, and maybe these ideas will resonate with some people and the world will become better. Just hoping. But again, not forcing that on anybody. So we're already streaming for 1 hour. So I think the time has come to make a small break and maybe even brew a cup of tea. So let's go. All right, we are back. And one of the things I want you to do, by the way, I want you to do an analysis of the components of the mesh of the model, right? So here's an interesting thing. So as I already said at the beginning of the stream, somebody warned me that there is an outer shell on the model, which may, if not handled correctly, prevent us from seeing the texture of Panger. Right. So it should be probably sort of like semi-transparent or something like that. So it's there to give it sort of cartoonish look, right? And we're probably not going to be doing whatever, you know, the usual, you know, software renderers are doing. Not really software renderers, but usual renderers are doing, like a Blender or maybe some engines and stuff like that. We're definitely not going to be doing that. And one of the things I want you to do, I want you to strip off that outer shell, preferably programmatically. So, and how can we do that? Because we don't really have like a shell as a separate component. All we have is just all of the vertices, then all of the faces, and like, where is the outer shell? How do I remove such outer shell? And there is thousands of the faces and thousands of the vertices. So what I was thinking is that maybe, I don't know that for sure, but maybe outer shell is actually a separate, isolated component on the mesh, right? So essentially you can think of the mesh as sort of a graph, right? I'm pretty sure it's a graph. And you have vertices, and vertices are connected into faces, which are triangles essentially. So you have a bunch of vertices. Maybe I want to actually make it a little bit brighter so it's visible more on that stuff. So we have a bunch of vertices like so, right? And they are connected into triangles like so, right? So this is a fully connected sort of component of the mesh. Then who said that in Blender you can't make something like this where you have another fully connected component of the mesh like so, right? So fully connected component of the mesh, but it's not connected to this component, right? So it's not connected to this one. It's just like a mesh consisted of two separate components, right? So, and my hypothesis is that maybe shell is just like a completely separate component. So, and if it's completely separate and not connected to anything else, maybe we can identify it programmatically and strip it off. Maybe, right? So how can we do that? We can just do BFS, honestly. What if the mesh isn't triangulated? What do you mean it's not triangulated? We literally have a sequence of faces which are triples of vertices. Did you just join this stream? Did you just join the stream and just said whatever the first thing that come to your mind after you hear this thing without understanding what the fuck we're doing? Mods, who didn't put submod on? Like, freaking... All right, whatever. So... Bad mods! Anyways, so, and one of the things I want to try, right? So I want to try to do BFS on them, right? I want to try to do BFS. And if you never heard about BFS, Google it up. It's actually a pretty cool algorithm, and I recommend you to learn about it. Right, so BFS wiki. So let's find it out. Let's find it out. Let's find it out. Oh, you mean by triangulated, that means they are shared or something like that. They're not shared properly. That's what you probably mean. Okay, mods on ban. I think I understand what they meant. Right, but we're gonna try anyway. So let's stop talking ourselves away from doing things, for fuck's sake. Right. So yeah, so this is an algorithm that basically sends a wave on a graph. On a subgraph, right? It sends some sort of a wave, right? You start from a particular vertex, and then from that vertex you send a wave to that vertex and that vertex. And you kind of have a list where you maintain the list of the wave, right? So essentially, currently right now, our wave consists of 2 or 3. Then, okay, I'm iterating through this entire wave and I'm looking at the nearest vertices that I didn't visit. Okay, so I go here to 4, 3 I already visited, so I don't go there, right? So the next wave is going to be 4, and in 3 in here, it's only 5, right? So this is the next wave. And from this next wave, I see that I visited everything and I stop the algorithm. And since I was marking the vertices that I visited, I know exactly the component, the isolated component, and I know that everything else is not part of that component. So that's basically the BFS algorithm, essentially, right? So, but I mean, there's, you can also use DFS in here, right? But BFS and DFS is just difference in the order that you are, traversing the vertices in. So I wanted to try to implement this kind of thing and just maybe analyze the amount of components we have in the mesh. Right, just to see if we can identify the outer shell, and if we can identify the outer shell, we can programmatically strip it off, right? So the idea is going to be maybe our OBJ2C tool on top of just parsing everything. It's also going to be traversing the mesh, right, and telling you how many components it found, right? So how many components it found. Right after, and basically maybe give you the list of components. Okay, so this mesh has these components, and then it will give you an option. Okay, you can strip off the 5th component, right? And we strip off the 5th component, and we'll then look at the rendered mesh, and maybe we'll be able to strip off the outer shell like that, or maybe not. I don't know. That's kind of the point of this experiment that I want to conduct. I don't know. Right, so, and the way I can learn about that is by just trying to do that. And I think it's kind of fun, right? So I haven't implemented BFS in quite some time. So I think it's going to be a pretty cool exercise. Even if it doesn't work out, right? Because I don't know if it's going to work out. But if it doesn't work out, I think it's still going to be a pretty cool exercise. So yeah, sounds good. Sounds Gucci. Tamaguchi. That's good. Anyway, so let me close this entire scheisse and let's see what we can do about that. So the way we're gonna be actually traversing this entire stuff, so I think we may want to start with a certain vertex, and then we need to be able, what are the neighboring vertices for that vertex, given the faces and stuff like that. And yeah, interestingly, maybe we can have some sort of an association, right? So you can take a look at the vertex and then you can see what face that vertex belongs to, like all the list of faces that specific vertex belongs to, right? So you can try to see that. Right, and so when you start traversing, you look at the vertex, you extract the faces this vertex belongs to, you iterate through all of the faces, and you just like visit each individual other vertex that is not visited yet. All right, and that's how we're going to be traversing this entire thing. And we can quite easily actually give that information as we parse the faces, right? So as we parse the faces, as you can see, we extract the vertices. We can then go find that vertex in an array of vertices and just add the current face index into that sort of vertex list somewhere. So we'll need to, for each vertex, we'll need to associate the list of face indices, right? So that's what we'll have to do. How do we parse vertices? Okay, so we have a vertices array. It's a dynamic array in here, and it's just it's an array of vertices, as you can see. So let's actually find, okay, so that's pretty cool. And it's basically a vector 3D, right? So the vector 3D is just this. Okay, so maybe we can actually introduce something like, vertex. All right, something like a vertex, and it's going to have a position, right? So this is the position of the vertex, and list of faces, right? So list of faces, like maybe it has to be something like faces. We already have a faces, and this is the thing, but we need to have, indices in here, right? So it has to be indices. So maybe faces indices, right? So face indices. Right, so this is going to be the faces. So, and the vertices actually is going to be vertex. It's a dynamic array. Vertices is a dynamic array of vertices. And face indices is actually a dynamic array of indices. So maybe it's going to be something like this. So it's going to be items, like so, and it's going to have capacity and the count and so on and so forth. So each individual vertex has sort of this thing associated with it. How many max faces can a vertex have? I don't know. And that's why we're making it a dynamic array. Look at that. Look at that. It's a dynamic array. So it has additional information like capacity count. So then our di append macro can extend as much as it wants. Right. So we don't know upfront how many faces it could be part of. And it doesn't really matter, right? So because we store that in a dynamic array anyway. Okay, so since I changed the definition of the vertices, so that means all of the code that is working with vertices is going to break. So we're gonna do a compiler assisted refactoring. So no build. So let's say tools. We're building the tools. So what do we have in here? So it's a struct, of course. Thank you very much. I do in fact know C. Okay, this one is interesting. So as you can see here, we are iterating through this thing. So this is the position, right? So I just have to do the position. It's very easy to fix. And when I'm pushing, okay, so this is very cool. Maybe I should introduce something like a make vertex, right? So make vertex, and it will automatically like create a vertex with empty faces. All right, so make vector 3, right? So this is make vector 3. And where is the make vertex, right? So this thing is going to return the vertex. It is going to accept the XYZ because that's what we need to have in here to create this thing. Right, so this is an XYZ. Vertex, like this, V. So the position is going to be make vector 3 XYZ. And I suppose faces, I just want to, can I just do something like this? I think I should be able to just do something like this, because when you use this syntax, it automatically cleans out the rest of this thing, so the face is going to be cleaned up. Right, so might as well maybe even just return, you know, the literal style kind of thing. Okay, that's fine, I suppose. Let's go here. Let's go here. What do we have? Where's the compilation? Okay, that's cool. So what do we have in here? I'm iterating through the vertices and I remap object. Ooh, this is so freaking cool. We'll do some sort of a remapping after. Holy shit. So we're normalizing this thing, I suppose. Yeah, oh, what the fuck, I didn't know this thing does that. So essentially, it does that to ensure that the object, when it's like rendered, it's always centered. I don't remember doing that, this is so cool. Holy shit, right, so it basically analyzes the ranges of X, Y, and Z, right? So just like analyzes and just like makes it fit into like one by one by one, and because of that it stretches that stuff, but at least it ensures that it's within the view, right? So that's why Panger is a little bit scuffed. Maybe I should actually preserve the ratios and stuff like that. That would be actually kind of nice. Maybe I'm gonna put it to do in here, right? So do rescale, maybe remap with preserved ratios of the object, right? So because if we take a look at how Panger looks like at the bottom there, it's kind of like scuffed a little bit, right? It's too stretched because we made it fit into one by one by one. Code seems to preserve ratio. Really? Does it preserve ratios? I don't think so. No, does it? Okay. Okay, I see. I'm an idiot. I thought it normalizes. For a second, I thought it normalizes. Yeah. So it's preserved. I'm sorry. Okay, I wasn't working with this code for quite some time, right? I don't remember everything it does, but yeah. But I thought it's a normalization of some sort. Okay, so preserve everything. Nice to see that. Nice to see. But anyway, whatever. Right, so what do we do in here? So this is the items, and what we want to do, we want to just do the position in here. Okay, so the rest of the things, remapping, and we are remapping the position as well. All right. So yeah, everything seems to be working, and let's actually see if I do assets, everything seems to be fine. That's cool. Now. So the face we have in here is rather interesting, right? So the actual index of the face is going to be the size of the faces, right? So we can say face index, right? So this is a face index, and this is basically the count, right? So that's what it is. It's this stuff. And as we parse each individual vertex, right? As we parse each individual vertex, can we assume that we already... Oof. So that kind of implies... This is hard, man, because what if it's referring to some vertices that are not there yet? They're not there yet. Damn, bruv. Damn. So that actually depends on vertices coming first, and then on faces coming next. unless we kind of iterate through the entire thing several times, focusing only on vertices or focusing only on faces and stuff like that. Does anybody remember, according to the standard, is there any like order restrictions, constraints that like vertices have to come first, or is it like you can actually mishmash them as like however you want? I don't really know. So OBJ format wiki. Right, if you can mishmash them, so we have to rewrite the whole thing. But not really rewrite, but at least restructure it. I don't think there is an order. Okay, that sucks a little bit. That is sucky-wacky a tiny bit. An object might contain vertex data, blah blah blah, connectivity between freeform, the most common object, geometric vertices. Okay, so Control F order. Okay, so the clockwise order. Okay, recording letter specify the order of the vertices which build the polyline. Okay. Yeah, I didn't see anything. I think there's a counter example in the models you have. You think? Let's take a look at that. Let's take a look at some OBGs. All right, so here's the Utah teapot, so vertices then faces. Okay, so then a low poly, vertices then faces. So maybe, since I don't really have any object as of right now that doesn't use like out of order things, maybe I'm gonna just assume that vertices always come first and faces always come next. Right, so, and put it to do in there saying that this is what we kind of assume. Right, so if we have a counterexample to that, like we'll have to restructure the code. But restructuring the code shouldn't be that difficult. So essentially, instead of a single loop with separate cases as we have in here, for each case we can create a separate loop. Right, so for example, first loop, we're only looking at the vertices. We're only parsing the strings that start with V, ignoring everything else. Right, one iteration, okay, collected all of the vertices. Next iteration, collecting all of the VTs. Right, collected all of the VTs, and then collected all of the faces. And we can do that in whatever order we want. Right. Why not load everything first, then do the BFS? So yeah, if we ever need like to restructure this entire thing, it's really easy to do. But right now, we don't have any examples where it's really needed. So I think it's totally fine. Okay, so let me see to do maybe node. Let's put a node in here. This code, it's actually kind of related to faces. All right, so let's put it like this. This code assumes that we already parsed all of the faces, but I couldn't find anything on Wikipedia regarding OBJ files regarding the order of the, what are they called, directives? How do they call these things? Are they called directives or the reference materials? So what is the collective elements? Okay, I think it's a good name. Regarding the order of the elements of the OBJ files. Right, but I couldn't find anything on Wikipedia regarding the order of the elements of the OBJ file. I should probably read the specs, but I'm too lazy for that. Right, I'm too lazy for that. Right, but since we don't have any OBJ files in the assets that have faces before vertices, it does not really matter that much. If we ever have any of such OBJ files, it's easy to restructure structure this loop to support any order of the elements So remember that the vertices that for the vertices they can be interspersed through the file. Only the order they appear makes the difference. Oh, okay, so that makes sense. Okay, so this is the official. Thank you so much. Thank you, OBJ format. I should probably maybe save OBJ file format. Okay, so the code assume that comes. Okay, so I should probably remove this part. Right. So the code said that we already parsed all of the vertices, but since we don't have any OBJ files in the data set, no, this kind of sounds weird. Since we don't have any OBJ files in the assets that have faces before, it doesn't really matter that much. If we ever have any of such OBJ files, it's easy to restructure this loop to support any order of the elements. Okay, so that's very cool. I can't really reformat it properly, unfortunately. My mode is too weak for that. I'm using a custom C mode for this kind of thing, so I have to kind of do it like this. All right, so this is basically the assumption we have in here, and maybe I'm gonna actually turn it into to do, right? So basically restructure this entire thing to kind of like support any order or whatever. So yeah, let me see. So how are we gonna be doing all of that? So we're gonna take the vertices. So this is gonna be V1. So it's an index, and it's not even you know, adjusted for, yeah, so we're adjusting this index like here, only here, but I suppose we have to do that up front. Wolfix W, thank you so much for Twitch Prime. Thank you. So maybe we should do that like as we parse things. It's kind of stupid, right? So let's actually not do that in here. Let's do that where we parse all of that. So might as well, you know what? I might as well just do that in here, right? So note -1 is to account for one based indexing. Is to account for one based indexing. All right. So we probably will have to do that for the VTs and VNs and stuff like that as well at some point, but it doesn't really matter that much. So yeah, so now everything is properly parsed and everything. So that means we can do vertices, items V1, and here's the faces, and we have to do DI append. DI append on each individual of them by using face index, like so. So this is going to be V2, and this is going to be V3. All right. So yeah, that's pretty much it. So for each individual face, we say, okay, so that vertex appears in these faces, right? So that vertex appears in those faces, and so on and so forth. All right, so we can try to do, we can try to build this entire thing now, right? So it's gonna be tools, right? Everything built, no problem whatsoever. When I'm actually rebuilding the assets, like I put a little bit of a statistics in here about the mesh that we parsed, right? So how many vertices we have, how many normals, and so on and so forth, how many faces. And one of the things, ooh, this one is weird. That's not that many faces. So this is OBGT pot. Is it that small? Wait a freaking second. Something is sus in here. Something is absolutely sus. So there's no normals, no textures. I remember having more of these things, or didn't I? Or I think it's okay. So let me actually stash everything I have, right? Because it's kind of sus. So we're building this thing, and then assets. Okay, so it was like that before, right? I suppose, like, I remember vaguely that it was like around several thousands, but I think I remember it from the teapot, right? It's teapot that has several thousands of vertices and faces and stuff like that. Okay, so that's basically the case in here. All right, so I'm trying to be a little bit careful in here. Okay, so let's try to have a little bit of a stats in here. Let's try to have a little bit of a stats. The stats that I want to have is minimum and maximum amount of faces each individual vertex can be in. Right. So that's the information I'm interested in. So how can we do that? So min faces, right? So min faces and max faces. So min and max. So here we have FLT. So this is int min, int max. Okay, so maybe I can just use int in here. All right, so it's going to be int, and here we're going to have int max, and here is int min. So for each individual vertex, we're going to be iterating all the vertices. We're going to just look at the amount of faces that vertex belongs to, right, and just like use min and max and stuff like that. Okay, let's iterate. So iterate through the vertices. So this is the count, right? So I'm iterating through all of them. And if min faces is greater than vertices items I faces count, then this is the new minimum. This is the new minimum of the vertices that we're dealing with, right? And the max, let's query replace min with max, boom. It's the same, but the opposite. So that's it, essentially. That's it. So there's a little bit of a duplication in here, so which is kind of annoying. Syntactically, it's kind of noisy. We could replace it with just count. Right, so, and just like assign it somewhere here, so something like that, I don't know. You just precast it to integer. So it's not count, it's count. So cout, it's like from C++. There we go. So that's syntactically less annoying to read, and we can now print that information somehow. So we can say so faces per vertex, right? Not sure how descriptive this thing is, but we can try to do it like this. Okay, so so min and max, min faces, max faces, right? So let's see if this entire thing even compiles. So this is tools, there we go, and this is assets. All right, so we have some, this is very interesting, look at that. So let's take a look at some of the app, like I forgot the new line, god freaking damn it, forgot the new line. All right, one more time. So this is going to be the tools, this is the tools, and then assets. There we go. So let's take a look at some of these things. Low poly cap, some of the vertices have 9 faces. They appear in 9 faces. For the Utah teapot, one vertex max appears like 40 times. So it's a part of 40 different faces. So this is kind of cool. Right, and for the penguin, for the panger, it's from 4 to 8. Probably the tip. Yeah, it's probably, yeah, it's the tip of the cap. Last Miles, hello. Right, so it's the tip of the cap. There's a lot of things like that in there, but at least we have this information now, right? So at least we have this information, and we can do a BFS, right? So we can now count the amount of components, right? So which is rather cool, I think. So at least count them, right? So at least counting them is going to be rather useful. We now can even extend the definition of the vertex, right? So the definition of the vertex, and we can say whether that vertex is visited or not, right? So visited. So as we do the BFS, we're going to be looking at the syntax stuff and seeing, okay, did we visit that vertex? Did we not visit that vertex? And that should be interesting. At least count, not identify certain components, but just like count them. And I think it's going to be rather interesting. So let me now try the following thing. So this is going to be assets, and I'm going to do the tools, and I want to rebuild the demos, right? So let's actually rebuild all the demos. Yes. Let me release the plebs, and let's take a look at the demos. So I just want to make sure that no models, no meshes are screwed up by our experiments and stuff like that. I just want to see that. And after we see that, we can try to do the BFS and at least count the amount of components. It would be kind of fun if the amount of components on the teapot is going to be like 4, right? The spout, the handle, the main body, the vessel, and the cap. Right, so it could be kind of actually kind of cool, I think. But anyway, so what do we have? So I need to go to here. So this is the assets, and let's take a look at the local host. All right, so all of the demos seems to be fine. Nothing is broken. Nothing is actually broken so far, which is really cool. Okay. All right, so how can we do the BFS? So we need to have a queue. To do a BFS, we need to have some sort of a queue. Right. So we have already face indices. So maybe we can have like a vertex indices. Why not? So it's kind of the same thing, but it's just like right, semantically different. It's semantically different. Okay, so I probably want to do BFS before printing the stats, right? So because it's going to be part of the stats. So here, what we're going to do, we're going to have vertex indices, right? So this is the current wave that we're having. So this is the current wave, and we're going to be on each iteration. We're gonna be computing the next wave, sort of speak. So to compute the next wave, what we need to do, we need to identify whether we have any unvisited vertices, right? So we need to find an unvisited vertex. Like how can we do that? It's actually a pretty easy operation, right? So it's gonna be something like this. I'm gonna be iterating the vertices plus I, and if vertices items I not visited, right? Not visited, I is the vertex that we want to work with, right? So it would be probably better to put that into a separate function, so to speak. Unvisited vertex, like so. So this is an unvisited vertex. And here we're going to be passing maybe just vertices, right? So vertices. We can pass it by value because the vertices structure itself is actually kind of lightweight, right? So it's only 3 64-bit numbers. It's actually 3 64-bit numbers because the actual data is stored in a heap. So and in here, right, so we just find the index and we return the index. So if we couldn't find it, we probably want to return like -1, right? So now if I go back in here, so here's the wave. And then we just trying to find the start, unvisited vertices, right? And essentially, while start is greater or equal than 0, we're just going to be doing the BFS, right? So we're going to be just doing BFS. So because we're going to be doing several BFSs, right? Several of them. We can have the amount of components, comp count equal to 0 in here. So, and then if we manage to go into that loop, if we have a single unvisited vertex, that means we have at least one component. So this is the start of the new component in here, right? So this is the start of the new component. We are going to be, counting it. So this is something that we probably want to put in here. Amount of components, right? So comp count, maybe components count. Yeah, there we go. So this is a comp count, new line. So and in here, since we're starting, I probably should push the start in here. So di append at the start. So we're doing the start. And while wave count is greater than 0, right, while we have something in the wave, we need to compute the next wave, right? So we'll iterating through the elements of the current wave, looking at their neighbors, and if we didn't visit those neighbors yet, we're going to be marking them as visited, and we're going to be adding them to the new wave. In fact, we can just reuse the same thing in here, right? So we can reuse the same queue in. Oh, this one is a little bit nasty because, yeah, it needs to be queue. So if we want to be using this single sort of data structure, it's better to just push at the end and pop out from the beginning. But if we don't have a queue, we need at least 2 arrays in here. 2 arrays in here. So if it's greater, so we'll have to be computing next wave, right? So this is the next wave, and we're going to be iterating through elements of the old wave, right? So these are the elements of the old wave. And honestly, we'll have to be switching between them. So to not lose any memory and everything. So wave count plus I, right? So, and if wave items, right, then we take a look at the vertices. So vertices items, yeah. So it contains the index of the vertex, and if the neighbor is not visited, right, it's not visited, that's the thing that should go into the next stuff. All right. So yeah, that's very interesting. So this is the, we should actually get that as a vertex, right? So this is going to be a vertex. I don't plan to modify it, and well, I mean, I do plan to modify it. So this is going to be this one. So this is sort of the current vertex. So this is the pointer, and we need to look at its neighbors, right? So it's going to be size j less than vertex faces count, right? So this is the faces count, and for each face, right, once we find that face, we have to iterate the each individual vertex of that face, and if it's not visited, edit it to the visited and stuff like that. And another important thing I forgot in here is that we need to mark that vertex as visited. So since this thing is not visited, right, so we need to go to vertices, items, start, visited true, right? So this is sort of the first thing that is visited. So here's the current wave. We add start to the current wave, and we say that it is visited, so we don't add ourselves to this entire thing. Akoya here, thank you so much for tier 1 with the message, Panger, your mom banger. Yes. Ooh, yeah, your mom banger. That's true. That is actually true. Anyways, so here's the face. But the problem here is that we can't iterate face vertices of the faces. Because look at the definition of the face. Look at the definition of the face. Where is it? Where is it? It's just these things. Which means that we probably want to make this thing an array. Because we want to be able to iterate this entire thing. And that means that all of these things should also become arrays and stuff like that. That prompts a little bit of a compiler-assisted refactoring. And I'm not sure if I want to go into that right now, but I mean, that sounds like a fun idea. So you know what I'm going to do? I'm going to actually comment out sort of this thing, this unfinished BFS for now, right? And I'm going to try to refactor faces to be arrays, right? Because that's what we want in here. So it would be actually kind of cool for this thing to be like actual arrays. What do you think? I think that's a good idea. Yeah. So my mouse is dead, almost dead, almost dead. So let's go ahead and just go to the compilation area. So it's going to be tools. So in how many places this mother flipper is going to break? So this is a count. Okay. So this is a code that should have been commented out, but I mean, wait. Did I not change this thing? Yeah. All right. Let's get started. So this is going to be 3. This is going to be 3. And this is also going to be 3. This is also going to be 3. I guess still arguing about this kind of shit. What is this? What is this botting? What are these bots? I swear to God, this is some sort of a bots. 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 So I wonder if this is going to work. This is a very interesting question. Can I just do something? Yeah, that looks epic. So, okay, so what do we have in here? I forgot a comma. What else? We're almost there. We're almost there. All right, so that's actually very easy. Well, look how easy it is syntactically to refactor these things into arrays. They were already but they are 0 based. Fuck. Oof. So this is dangerous, bruv. This is dangerous, brovsky. Fuck. Brovsky. We need to find all of these, like, V3. Okay, so this is the only easy refactor, yeah. God fucking damn it, mate. God fucking damn it. It was actually all debate. So was it already that? So yeah, that's fine. That's totally fine. Okay. Yeah, I could have just used the union. That's true. But I mean, I already refactored it. If there's nothing on the line 418, you're banned, perma-banned. Get fucked! Think you can debate Zojan? I think you can debate Zojan. I've been doing that for almost 10 years, bro. I've been streaming programming for almost 10 years. You think you can debate me like that? You really fucking think you can debate me like that? Easy. Anyways, so now let me see. So component counts. Everything seems to be fine. So I want to try run assets, and let's actually rebuild all of the demos just in case. Chat only, yeah, I also think so. I think the time has come for chat only. So let me see. So everything seems to be working. Everything seems to be working. All right, so as you can see, chat, everything's fine. Nothing is broken. I don't know why you're fuzzing about. So let me see. So now we are actually have the thing where we can iterate through the rest of this stuff. Right, so we're iterating the faces, right, and then we're gonna be iterating through all the vertices, right? So we can do something like this. But it's kind of dangerous in a sense that what if we change the amount of vertices per face? What if we change the amount of vertices per face? So we need to have something like an array len. So, and if this is the face, you know what? So vertices per face. This is probably what we want to have in here. Vertices per face. Vertices per face, and there are going to be 3 of them. So I just want it to be like a very obnoxious in case I want to change the amount of vertices per face. I'm probably not going to be doing that, but if I were to ever change the amount of vertices per face, I want it to be as obnoxious as possible so I don't forget to modify some things or whatever. You know what I'm talking about? So, and here I might as well do something like a static assert and just say that in here we kind of assume the amount of vertices per face is to be 3, right? Right, so yeah, something like that. Vertices per face, please don't modify. Yeah, exactly. So like I don't know what to put here, so it's gonna be just like empty. So, and like I just don't want to have some sort of like weird magical constant in here, right? I just want to have this thing to have like a meaningful name. Right. Okay, finally. So this is like a lot of nested things. So we iterate in the wave, right? So then we take in the vertex, and then we have the faces that vertex belongs to, and within that face we're iterating all of the elements of that face, and we need to check whether they're visited or not. So we need to do vertices items. Right. So this is like. Ooh, this one is rather interesting. So this is the face. So this is the faces. So it's a items. It's a J's face we belong to, and there's also. But this is just an index. That's what's interesting. So that means it's items of the faces like that, and then we just do K. I hope I didn't fuck up anything in here. So essentially we are, we are doing like an index chasing, right? So we're doing like a index chasing. So here's the current vertex in a wave. We're taking jth face this vertex belongs to, right? And then we looking up that face, and within that face we're taking case vertex, and this is the neighbor index actually. So this is the neighbor index. That's what it is. We can do something like a neighbor index. That's what it is. And then within the vertices items neighbor index, if it is not visited, for whatever reason, we need to add this thing to the next wave. Right, we must add this thing to the next wave. So it's going to be di append. All right, next wave, add that neighbor index. It's a little bit complicated, but it's just like a complicated data structure, right? So it's kind of a complicated data structure. So I don't know. All right, so here we processed the entire current wave and we constructed next wave. That's what happened in here. Actually, that's what happened in here. And essentially what we want to do, we kind of want to swap out current wave and the next wave, if that makes any sense. We want to swap them out. So I probably, because of that, I want to keep next wave somewhere here. Right, I want to keep it somewhere here. So after we processed the old wave, we might as well clean it out. So I'm going to set count to 0. And now we need to swap somehow the waves. And I wonder if I can just use the regular swap algorithm, right? So this is just like a temporary wave, then wave, next wave, and then next wave is going to be temporary. So I just want to swap them out. Since vertex index is actually a very lightweight object, it's not going to be a very expensive operation, because what we're doing, we're swapping 3 64-bit numbers, right? So it's just dynamic array. Right. So this is basically what we're doing. That's the BFS. Right. And every time, right, so this is a single BFS we perform in here. And at the end of a single BFS, we have to repeat this entire operation one more time. Right. So does that make any sense? What we're doing in here, we're counting the components. We're starting by finding the first unvisited vertex. Let's double check. Right, so the first one that is unvisited, there we go. So it's greater than 0. If we found the first unvisited vertex, that means we found one component already. It makes sense to just like count it. Okay, so now we allocate 2 data structures for maintaining the wave, right? So there is a current wave and the next wave, which can be constantly swapped out. So we adding the found start vertex to the wave and marking it as visited, right? While we have something within the wave, we processing the wave. By processing the wave, we mean we compute in the next wave. We iterate in each individual vertex. Here's the current vertex. We iterate in each individual phase that vertex belongs to. For each individual phase that vertex belongs to, we iterate each individual vertex of that phase, meaning that all of the neighbors and including that thing. Right, so, and we take in this entire thing. So, okay, so here's the current vertex. We take in the jth phase. We're looking at that phase, and within that phase, we're looking at vertex. Here's the neighbor index. And so we're only looking at the vertices that are not visited. Since us ourselves are already visited, that thing is going to exclude ourselves. Then we adding it to the next wave, and we need to mark this thing as visited as well. So this is something that we missed. So this is why I like to go through complex algorithms that I write one more time so I don't miss anything. By the way, if you're a competitive programmer, you probably know this kind of thing. Like you can probably type it out like very blindly. Since I'm not a very good competitive programmer and I haven't had any practice for quite some time, so you see I'm very slow on that. So yeah, so visited, of course. All right, so, and this entire thing should construct a new next wave that should be used on the next iteration. Since we process the old wave, we kind of just reset the counter, and then we just swap them out, right? So temporary, we save the wave, so that means we can modify the wave, we put next wave, and that swaps out this entire thing. 2 arrays instead of queue, exactly. So this could have been much easier, like we wouldn't have to do these weird tricks if we just had a queue, but I don't want to implement a queue. I don't really have it in this language and I don't want to implement it, so it's easier to just have 2 arrays. So it kind of supplements that. What's funny is that I kind of invented this technique myself. I never looked it up anywhere, but I'm pretty sure it's a really well-known technique, right? So, but I kind of came to that technique myself, right? So instead of queue, just 2 arrays. I have just recursive algorithm for depth first. The recursive algorithm, they are dangerous in the sense that they can stack overflow, right? And what's interesting is that we have here thousands of the vertices. Like, the meshes are pretty complex, so I didn't think recursive algorithm is a good idea in here, unless we just extend the size of the stack, but I don't want to be fiddling with that. Yeah, so I think the recursion will explode in here, so it's better to just do it like this. Okay, so that's basically what we have in here. Let's try to build it. It may actually hang, right? So because maybe I made a mistake somewhere here, so we'll see. So let's do tools. So what do we have? Static assert. So implicit declaration of function static assert. Okay. I suppose we need to include assert in here. So because I'm sure it has to be included in here. So implicit C99. Why do I explicitly say that it has to be C99? Does anybody remember why I explicitly said it's C99? Like why? I don't remember honestly, but anyway. So there's start. Okay, so we're adding that to wave, so that's understandable. And there's another thing. Undefined, yeah, so it complains about Brovsky. What the fuck, Brovsky? How come? Can I just have recursive with trampoline? Maybe. Is that a good idea to just switch to C11? Because I kind of want to have a static assert. What do you guys think? But anyway. So if it works, it works, yeah. Let's take a look at the assets. 10 components with Pango. Holy shit! Utah Teapot has 4 components! Fucking called it! I'm sorry for being too loud, but I mean, this is so fucking cool. Remember how I said that the Utah Teapot is gonna have 4 components? Spout, the body, the handle, and the cap. Here they are, 4 components. Here they fucking are. Man, this is so fucking cool. Yo. Okay, so, and the Panger has 10 components, right? So, which is a lot, but I mean, that's fine. Low poly cup, right? So you can even take a look at that, right? So there's obviously 4 components in here, right? So it's just like a spout, handle, and body, and the cap. So this one obviously has 2 components, right? It's like the handle and the vessel. What's the official word for that, right? So here we have 10 of them. Well, I mean, I'm pretty sure like each leg, body, and beak, they are separate components. So beak, body, left, right hand. And if there is an outer shell, maybe outer shell actually mimics them. So there's at least 8 of them. So if there's 10 components, there's maybe something additional, like 2 additional components, 2 separate additional components. So author of 3D Panger must confirm the parts, maybe. The eyes. Eyes, I thought eyes are like, how to say that, like texture. One component of the Panger, huge dick. Well, I mean, it's just like ball sack and the dick itself, right? So the 2 missing components, right? So we found them. The 2 missing components. Only one. Well, I mean, just to save on space, just like you know, in the shape of a heart, just a ball sack, like an inverted heart, ball sack, and so 2 components. But anyway, so what I want you to do, how can we strip off those mother flippers? That's very interesting. We need to, the way I want to strip them off is that I want to have an index, right? So I want to specify, okay, strip off nth component. Stripping off nth component is going to be a matter of removing vertices belonging to that component. Not even vertices, but faces, rather faces. So, yeah, that's gonna be fucking interesting, I suppose. It's gonna be fucking interesting. What I'm thinking, broskis, I think we need to reform visited field of the vertex. So essentially, we want it to be a component. 0 means this mother flipper does not belong to any component. And then 1, 2, 3, and so on and so forth means the index of the component it belongs to. That way, it may act both as the visited field, which denotes that, like, we already classify that vertex as being part of the certain component, or as not visited. Right, and as soon as we did the entire BFS, each individual vertex is going to have an index of the component it belongs to. Five head idea. I think it's pretty cool. I really like this idea actually. So let's give it a try. Let's give it a try. So, and we already have like the current component because we do comp count, and that's basically the index of, holy shit, it's all fucking coming together. It's all freaking coming together. Holy shit. Anyway, so let's actually go to the compilation errors. Let's go to the compilation errors. So it's gonna be tools. Yes. So visited. I can literally just do not components. Right, so because 0 indicates that it's, so it probably makes sense to actually denote that. So 0 means never visited, greater than 0 is the index of the component vertex belongs to. Refactoring will be nice, yeah, so it's gonna be super easy. You just follow these things, and here I marked as visited, but now I have to give it an index. And what is the index? It's comp count. It's a comp count. Right, so it's super easy. Right, so it's actually super natural. That's cool. So not visited, components, not component, comp count. Oh, right. Yo, component. Okay, that's pretty cool. So now we need to have some sort of a field, I presume. So it's going to do assets. It's still super fast, by the way. Doing all of the analysis of all of the assets we have 4 OBJ files. One of them has 3,000 vertices and 6,000 faces. Analysis and transformation of all of them is below 100 milliseconds. One base component index, yeah, unfortunately, right? So this is something that we have to deal with. C is fast confirmed. I don't think C is just like a bullshit free, right? It's fast because it just like does minimal amount of bullshit, right? So that's why essentially. We can now have a flag. So let's have something like, how are we going to be doing all of that? How are we going to be doing all of that? So we take a look at the face. Face has 3 vertices, right? So this one is rather interesting. So we're gonna be deleting components by deleting faces, not vertices. So that's kind of important. So we're gonna keep the vertices in, but we're gonna delete the faces. So you have a face which is 3 vertices. Right, so which is 3 vertices. All right, so I look at the face, and I look at its vertex. And I don't include the entirety of the face. Into the final generation if any of the faces belong to the component that we're trying to remove. I think that's the way to go about that, right? So that's an interesting way to do that. So that way we can, and it's super easy to test, by the way, especially with the Utah teapot, right? So it has 4 components, and deleting one of the components is going to be very profound effect, right? So it's just the entire spout will disappear, or an entire handle will disappear. So yeah, I think that's going to be the way we're going to go about that. All right. So here are different sort of parameters and the flags that we have in here. So I suppose we're going to have a like delete component, and initially it's going to be 0, right? So how we're gonna be doing all of that? So I suppose the flag for deleting a certain component is going to be strcmp flag d is going to be 0. All right, and we have to provide the value. So let's copy paste this check. and then we can parse the value. So the way we parse the value is rather interesting. Right, so here's the value, we extracting it, and delete component. So A to I think that's what we want to do in here. Is that what it is? A to I. So it converts a string to an integer, and that's precisely what we want to have in here. Let me try to recompile the whole thingy-majingy. So it's going to be tools. It's going to be tools. Delete components as never used. Okay. So here we are generating things. So we are generating the code. We are generating the code. So we go through the vertices, through the faces. So the thing is, we also need to print the amount of faces we've got. So we need to kind of know this up front. So delete components. Let's pass this information in. And yeah, delete component. All right. So again, the way we're going to be doing all of that, we're going to be looking at the faces. All right. So faces count 0. For all of these faces items I. We probably want to have some sort of a function. Is deleted face. We have to provide the vertices, the current face we're deleting, and the deleted components. Right. And if it's not a deleted face, we say, okay, so this is part of all of the faces. Right. So this is part of all of the faces. And this is what we're going to be using instead of the faces count, right? So this is like, let's call it visible faces count to just distinguish it from the actual faces count, right? So it's going to be visible faces count. And in here, visible faces count, like so. Cool. I'm really happy to see that. So, and then after that, we just reuse the same thing in here like so. So we need to now implement this function. Let's put it in here. So it's going to be obviously Boolean. It's going to be accepting vertices, and the face. So is face a very big structure? No, it is not. I think it's totally fine. So we can actually afford passing it and deleted component. Okay. Why are you doing that, Brovsky? Okay. So what we're going to be doing in here, we're going to be iterating through the vertices, right? So basically vertices per face, like so, plus I. Lucy will be the blender like array leap to Unity, maybe. So if vertices items face vi component equal to delete component, return true, otherwise return false. Isn't that poggers, my friend? Isn't that poggers? I think that's pretty freaking poggers. Oh shit, it only occurred to me. Wait a freaking second. Wait, people were spamming ++J because... Fuck, and I banned that person. Okay, just a second. Okay. I just unbanned them. Did it unban them actually? I don't know. I don't know if it unbanned them. Oh yeah, okay, so it's not banned in this chat. Grilled guest, if you're watching it right now, I'm so fucking sorry. It This only occurs to me now. Like, holy shit. I'm such a fucking idiot. Like, I swear to God. Sometimes when I used to watch my VODs back, I would be looking at the shit I do and just like, bruh, you so fucking stupid. Like, holy fuck. But again, I'm streaming. Like, half of my IQ is actually engaged in like trying to keep up with all of that stuff. So, all right. Anyway, I'm sorry. So the stuff like that happens to me from time to time. So I apologize. Anyways. So deleted component. So let's actually try to rebuild the whole thing. So faces count, it's a visible faces count specifically, right? So it's a visible faces count. And okay, so that seems to be working. That seems to be what it's working. So how about that? But you didn't expect that shit to happen. So now, let's actually go to nobuild. Let's go to nobuild, and I want to go to build assets, and for the Utah teapot we can try to delete something. Let's delete the first component. Let's try to delete the first component. Okay, so I'm rebuilding the tools. Cool. I'm rebuilding the assets, and I'm rebuilding the demos teapot 3D. I think that's the one I'm going to be rebuilding. Okay, let's refresh the whole thing. Surprisingly, the first component also includes spout. But nonetheless, this motherfucker just works. This entire freaking idea actually works. Alright, so I'm gonna actually reduce the class because apparently they were not trolling me, you know, back then. So, so yeah, I was just stupid. So we can actually identify certain components and we can remove certain components. This is fucking cool. ++J. Anyway, so let's try to maybe remove other components, right? So let's take a look at the second component. What if I remove the second component? So no build assets and rebuild the whole thing. Utah lead underside. Okay, so the second one is probably Utah lead underside. Components 1 base, because 0 means no components deleted. So I suppose it's part of the, you know, lead. One of the components is actually part of the lead. Okay. Okay, so it's probably, I can't really rotate it properly, unfortunately. So yeah. And probably for the panger, we'll have to delete several components in there at some point. We'll probably have to delete several components. So what about the fourth component? Suppose the fourth component is a spout. And this is a spout. Okay. Man, this is such a useful, this is a very fucking useful tool. What the fuck? Like, this is unironically useful. Unfortunately, right now, we can only delete one component at a time. Right, one component at a time, but we can easily add deleting several components, right? So, Utah bowl, yeah, this is a Utah bowl without any spout. So, and I just like assume that maybe outer shell is, yeah, several components, and I'm not sure how easy it would be for us to see that. Like, if, for example, outer shell of the body is one separate component, deleting it would not be apparently visible for us. So it will be just the body has shrunk. We need a way to have to compare pangers side by side. Color the components differently. That's an interesting idea, but the demos don't have information about the components yet. We do not propagate that information to the demo. So it's something that our processing tool only knows. We could actually add that information, actually. That's an interesting idea, honestly. Yeah. If you don't see what got removed, you remove the correct thing on. Technically, yeah, I guess technically that's true. All right, so this is a very cool freaking feature that we got in here. So, and if I just don't delete anything, right, if I just don't delete anything, right, I think texture and when, probably not today, because we're already streaming for more than 2 hours, so it's a little bit too much for me, so it's a bit too stressful. Yeah, so now we have the entirety of the thing in here. And man, today's stream was actually kind of cool. So I think it was kind of cool. Alrighty. So I think I'm gonna commit this entire thing. So what exactly did we do in here? I suppose we just added the ability to delete components of the thing. Right, an ability to delete components. So obj to C, implement -d flag that deletes components of the mesh. Right, I'm gonna push that right into the repo. What about moving components so they separate in the grid? We can also do that, can't we? Since faces, they are just meta information that connects together vertices, and we know which vertices belong to which components, we can just iterate all the vertices, find the vertices that belong to a certain component, and do modifications on them. That's actually kind of cool. So we can manipulate certain components in whatever way. I think I saw that obj-c can handle multiple of the same flag. Well, probably, actually. Wait a second. That's a cool idea. Just a second. We can just have this as an array. So essentially, every time we encounter D, we just append that delete component to a dynamic array. Okay, so components struct component indices. That's a cool idea. So int items size count capacity component indices delete components, and this is basically empty. So let's actually go to the compilation errors super quick. So it's going to be tools. All right. So, and in here we're going to just do da append like so. I think I need to call it components to indicate that it's plural. All right. So generate code component indices. I think it's yeah, it's defined down there. So let's actually define it up there. And let's pass all of that information there. So delete components. So is deleted face components indices. It's probably again defined 2 below. I really hate C in the sense that like it's so old-fashioned, right? So you have to define types in a certain way. It's just like so annoying. All right, so for size tj j less than delete components count plus I. Right, so and delete components items j, so it's like, okay, I'm joking. So I think that's the thing we want to do in here. That's the thing we want to do. All right, so let's go to the compilation errors. Component s, it's plural. It's plural. Delete component s. Delete component s. Delete component s. Ooh. All right, so now I'm gonna go to nobuild, and essentially, meine Freunde, I can delete several of them. So what if I delete 1 and I delete 3. What would you do now? What would you do now, my friend? Alright, so let's refresh this entire scheiße. It didn't fucking work because I didn't properly rebuild assets. I need to rebuild the assets and then demos teapot 3D. Alright, so that's what I need to do. Refresh this scheiße. Fuck me. Didn't work. Why didn't? Okay. I'm sad. Why it didn't work exactly? What did I fuck up? What did I fuck up? Di append, so this is empty. Alright. So when I generate the code, I just check whether certain thing is deleted or not. I'm checking it several times. It must be some problem in here. It must be some problem in here. So this is a component. Delete components. Yeah, so if any vertices of the current phase is part of the deleted components, it's just like instantly true. So what did I miss? What did I miss in here? Like I missed something obvious. So components count, maybe it makes sense for me to print the deleted components, right? Deleted components, like so. And the way we're gonna do that, I'm gonna iterate through the deleted components essentially. So because I'm not sure if it's correct, delete components count plus I. So and essentially what we're doing in here is just space D, delete components item I, and then just print f plus j. Okay. Oh, I suppose okay, I need to also rebuild tools. This build system sucks ass. So yeah, okay, so probably, yeah. I think I know what the fuck is going on, brovsky. Brovsky, I think I know. One more time. Yeah, so here are deleted components 1 and 3 because we explicitly said so. These are the deleted components. My mouse is fucking dead, bruv. Okay, so now as you can see, we deleted several components, I suppose. So one of them is the tip of the lid. I just remember the name. So you're supposed to see the tip of the lid in here, but you can't see that. Right, so we can actually now delete several components. Thank you so much for whoever suggested that. Right, so we can try to delete some of the components of Panger, your mouth is banger. Okay, so D1, let's delete the first component. So let's go. So thank you so much everyone who subscribed. By the way, I was neglecting the subs. I really apologize for that. Just a second. So Miralai Koshka, thank you so much for Twitch Prime with the message printf. Hello world indeed. Unlimited Quarter 2, thank you so much for Twitch Prime. Nuligor, thank you so much for tier 1. Thank you, thank you, thank you. So let's take a look at what we got. So as somebody said, we deleted the right component, I suppose. I don't know what's the difference between them, honestly. I might as well, actually I have an idea. I may delete, so I can put 0 in here and it will not delete any components, right? So it's actually kind of convenient. And I'm going to refresh the whole thing. I'm going to rebuild the whole thing. And I'm going to keep this thing open. And I'm going to open it side by side. So is it rebuilt? I think it's already rebuilt. So, oh boy. Oh boy, oh boy. I didn't see any difference. I guess it did in fact deleted a huge dick. Invisible. Is there any difference really? maybe it's going to be visible from behind. Nah, it's kind of hard to see. Maybe delete all and add one by one. That's an interesting idea, actually. Delete events, then odds. Huh. I don't know. So it's better would be to actually color them differently. Looks a little thinner, but yeah, hard to see. Yeah, that's exactly the problem. So we can delete certain components. It's totally fine, but it's hard to tell which one we have deleted. One of the things we can do, okay, we can actually just implement the texturing as it is without deleting any components. Just implement the texturing. Then, as soon as we implemented that, we can start experimenting with different components, removing them and seeing if that reveals the texture or not. This is one of the things we can do. But we're not going to be doing it right now because I'm already streaming for like a third hour. It's already almost a third hour. So I think it is time for me to go. Right, so yeah, that's it for today. Thanks everyone who's watching right now. Today's stream was actually kind of cool. We implemented cool stuff. I really appreciate everyone watching. Have a good one, and I see you all on the next recreation programming session with Ahu Amista Azozin. I love you all. Mwah.